welcome to the June 2015 Regents exam in chemistry. This is a walkthrough of Part A. This part of the exam consists of 30 multiple choice questions from throughout the curriculum. To skip to a particular question, or to view the answer key for this part of the exam, click on the Index button that appears in the upper right corner of the screen. Here is question number 1. Compared to an electron, which particle has a charge that is equal in magnitude but opposite in sign? This question requires knowledge of the basic subatomic particles. You can see among the answers we have alpha particle, beta particle. These are nuclear particles. And then we have the neutron and proton. These are basic subatomic particles. So let's take a look at these different particles and see if we can surmise an answer. Protons, charge +1. Electrons, charge -1. They clearly have opposite charge but equal magnitude. They're both 1s, but one's positive, one's negative. So they're a perfect fit for this answer. Let's go back to the question. We're comparing to an electron. We know that the proton has exactly opposite and equal charge. So proton is going to be the correct answer. The neutron has no charge. The beta particle, if you recall from nuclear chemistry, has a -1 charge. So that's the same as the electron. The alpha particle is positive, but the alpha particle's charge is +2. That's too big. So we're going to stick with answer number 4. That would be the proton. Question number 2. The mass of a proton is approximately equal to, this is another subatomic particle question, so let's go back to our little chart. Subatomic particles, they're asking about the proton. We already described its charge as +1. Here's the mass. You need to know that the basic subatomic particle mass values, the proton and neutron are pretty much the same at 1 atomic mass unit. It's the electron that's super small. It weighs in at approximately 1/1836th the size of a proton or a neutron. So our answer here is 1 atomic mass unit. Answer number 1. Question number 3. Which property decreases when the elements in group 17 are considered in order of increasing atomic number? So let's take a look at group 17. Here they are, and they're in order directly from the periodic table. In increasing atomic number, we go from 9, 17, 35, and 53 with iodine. And I've looked up various values, the ones that they're talking about from table S, radius, melting point, and electronegativity. Those are 3 of the possible answers. So they want us to consider the mass. Mass values are right on the periodic table. You can see that they're increasing as you go down through the column of elements. The atomic radius, here's the radius values. These are from table S. You can see clearly they're getting larger, and the reason they're getting larger is because we're adding more and more shells of electrons. The melting points, we start at 53, 172, 266. Clearly that also is increasing as we go down through the column. And the melting point, by the way, is increasing because as these atoms become larger, they have stronger forces of intermolecular attraction in their structures, so it's going to be more difficult for us to get them to change phase. And then finally we have electronegativity. Now electronegativity is related to the attraction between the nucleus of the atom and its valence electrons. Fluorine is the strongest at 4.0, and you can clearly see these numbers from table S show us a decrease as you go from top to bottom. So the answer is going to be electronegativity, and I realize this is a lot of work to look up all these numbers and chart it out like this, but the main thing to remember is that because atoms are getting larger as you go down through the column, the valence electrons become less and less attached to their nucleus. So we go back to our answers. We're going to select number 4 for this question and move on. Question 4. Any substance composed of 2 or more elements that are chemically combined in a fixed proportion is. This is flat out the definition of a compound. Answer number 4. Just to review the other decoy answers that they put in, here are the definitions for those terms. The first response, isomer. Isomers are structures that have the same parts, but they're arranged differently. We run into isomers when we're studying organic chemistry most of the time. Isotopes from atomic structure, these would be atoms that have the same element but different number of neutrons. So they have equal numbers of protons, but their number of neutrons may vary. For example, a carbon-12 versus a carbon-14 atom. The carbon-14 has 8 neutrons, while the carbon-12 only has 6. So their masses are different, but they're still both carbon. A solution is any mixture where one substance dissolves into another, and these mixtures can have varied composition. You can put a little bit of solute into a lot of solvent, or you can put a lot of solute into a little bit of solution, you can vary that composition. And then that leaves us with the compound, and again, this question gives us the definition of a compound: two or more elements chemically combined in a fixed proportion. Answer 4. Question 5. Which term refers to how strongly an atom of an element attracts electrons in a chemical bond with an atom of a different element? This again is a definition problem, and they've given you the definition of electronegativity right there. So it's going to be answer number 2. Let's just rule out the decoys here. Entropy is the degree of randomness that you have during a process, a chemical process or a physical process. Activation energy is energy needed to get a reaction started. And the first ionization energy is the amount of energy you need to remove the outermost electron from an atom. But electronegativity is defined the way it's defined here in question number 5, answer number 2. Question 6. At STP, which substance has metallic bonding? Well, to have metallic bonding, the substance has to be a metal. So our pure metals are the substances that will illustrate metallic bonding. The first two responses, ammonium chloride and barium oxide, these are both compounds, and in fact they're both ionic compounds. So we're going to rule them out because they're not even elements, so we can't consider them metals at all. So what we're asked to do really is to decide which one of these two things is a metal. The answer should jump out at you, but in case it doesn't, you can find them both on the periodic table and keep in mind where the zones reside. Here's the silver, here's the iodine. Silver is a member of the metal classification, and iodine is clearly a non-metal. So our answer is going to be the silver. Answer number 4. Question 7. What is the number of electrons shared between the carbon atoms in a molecule of ethine? Okay, this is an organic chemistry question as well as being a bonding question. So first we've got to know what ethine is. Now, I've got some diagrams here which include ethine. So we have an actual picture of ethine, but what's going on in these diagrams is that we're looking at organic compounds where carbon atoms are bonded to hydrogen atoms and other carbon atoms. And you can see in the first case the ethene molecule has a double bond with the carbon. The propene has a double bond between the carbons. The ethine has a triple bond between the carbons, just like propyne does. So the structure we're really looking at is this one. It's the ethine. And they're asking us about the number of shared electrons between the carbon atoms. Now, each of these lines in our structure represents a bond between the two carbon atoms. And they're covalent bonds, and covalent bonds are actually the sharing of 2 electrons. So here we have 3 pairs of 2 electrons. 3 pairs of 2 electrons means that we have a grand total of 6 electrons being shared in this triple bond. Our answer is 1. Question 8. Which atom in the ground state has a stable valence electron configuration? These 4 atoms all have valence electrons of differing numbers in them, and we can find out how many valence electrons they have if we find them on the periodic table very quickly. Now, a stable valence electron configuration is a configuration that has 8 valence electrons, unless you're talking about very small atoms where the first energy level is the valence shell, in which case 2 electrons would be stable. But all of these are large atoms. They have 3 shells of electrons. Argon is the one with 8 valence electrons. That's the stable octet. Argon is our answer. It's number 1. It's also a noble gas, which that should bring to mind very quickly to you that it's going to have a stable valence electron configuration. Question 9. What occurs when 2 fluorine atoms react to produce a fluorine molecule? We're assessing 2 things here. What's happening to the energy and what's happening in terms of bonding. Well, if you take 2 separate fluorines and you add them together to get a fluorine molecule, you clearly are forming a bond. So let's throw away the answers that say bonds are broken. And then you should recall that when you form a bond, energy is released. So we're going with answer number 4 by definitions and by logic. Question 10. Which gas sample at STP has the same number of molecules as a 2-liter sample of chlorine gas at STP? So we are kind of told here that they're at the same temperature. So let's recall our rules about these gases. For any gas, you will have equal number of particles as long as you have the same temperature and equal volumes. There we go, equal volumes. So if you want something that has the same number of molecules as your chlorine gas, 2 liters, you need 2 liters of some other kind of gas. That's going to be answer 2. It actually doesn't matter what these formulas are as long as they're gases, because any gas is going to have these same properties, provided they have the same temperature and same volume. Question 11. All atoms of uranium have the same what? Okay, you should recall that the atomic number of an atom gives you its numbers of protons. So, if they have the same number of protons, which they do because they're all uranium atoms, they must have the same atomic number. It's answer number 2. Do they all have the same mass number? Not necessarily. Because of the existence of isotopes, we know that we can have a variety of uranium atoms with differing masses. And that's because they have differing numbers of neutrons. So these 3 answers are all kind of related to each other, and they all represent isotopes. But we're not looking for isotopes here. We want to know what's the same. What do all uranium atoms have in common? And that's their atomic number. Question 12. The concentration of a solution can be expressed in which units? They give you 4 choices here. You should recognize all of these units and know what they're used for. And number 4 should jump off the page to you. Moles, a quantity, in a certain volume. So moles per liter is a valid way to measure concentration. For review purposes, kelvins measure temperature, milliliters are a measure of volume, and joules per kilogram is a measure of energy in a particular amount of mass. So it's an energy measurement. So our winner is number 4. It's moles per liter. Moving on. Number 13. Compared to the boiling point and the freezing point of water at 1 atmosphere, a 1 molar calcium chloride solution at 1 atmosphere has what? Well, the difference between these 2 things is that the calcium chloride solution has ions dissolved into the solution. And when you dissolve things into a water solution, you take on additional properties known as the colligative properties of the solution. Those ions that are now present in the water will interfere with the freezing and boiling processes. So it'll become more difficult to freeze and more difficult to boil the substance. So we refer to the freezing point change as the freezing point depression, and the boiling point change as the boiling point elevation. You have to lower the temperature even more to freeze it. You have to raise the temperature even more to boil it. So the answer that corresponds to this is that we're going to have a higher boiling point and a lower freezing point. It's answer number 3. Number 14. According to the kinetic molecular theory, which statement describes an ideal gas? Well, let's review the kinetic molecular theory quickly here. These are the main bullet points that make up the kinetic molecular theory. The first, gases are made up of particles. They can be molecules or atoms, and they're in constant straight line motion. Gas particles, when they collide with each other, the collisions result in a transfer of energy, but there's no net loss of energy. Gas particles are separated by great distances, and the gas particles do not attract each other. So now let's review the answers and see which one is valid. Gas particles are diatomic. They can be, but they don't have to be. Energy is created when the gas particles collide. No, energy is not either lost or created. There are no attractive forces between the gas particles. Yes, that was the last thing that we had said. 3 is the correct answer. And just to make sure and be thorough, the distance between the gas particles is small. No, it's large compared to their size. So we have 3 decoys and 1 correct answer. Question 15. Which physical change is endothermic? Well, before we go any further, let's make sure we know what endothermic refers to. An endothermic change is one in which the reactants absorb energy. So we're looking for a physical change here where we are adding energy to the reactants. So if we take a solid and we change it to a gas, that certainly is an endothermic process. That's the best answer right there. But let's rule the others out. You have to add energy to a solid to get it to change to a gas. A liquid to become a solid, that goes in the other direction. We have to take energy away to slow down the particles so that they can come back together. Gas to liquid, same thing. You have to slow the gas particles down by removing energy from them. And gas to solid, yes, you've got to remove a lot of energy from a gas to get it to the point where it will be a solid. So our answer is 1. The carbon dioxide solid absorbs energy and converts to carbon dioxide gas. Answer 1. Question 16. Which group 16 element combines with hydrogen to form a compound that has the strongest hydrogen bonding between its molecules? The strength of hydrogen bonding and intermolecular force is controlled by the degree of difference between the hydrogen and the other element, difference in their electronegativities. So if we take a look at our potential answers over here, and we look at their electronegativities, we see a range starting with oxygen, the greatest at 3.4, down to the tellurium, 2.1. I'm going to throw out the middle answers, because here we're asking for an extreme answer, so we're going to throw out the middle runners. So what we're looking for is a big difference in electronegativity. Hydrogen's electronegativity is 2.2. So you can see the difference between the 3.4 and the 2.2 is going to be 1.2. And the difference between the tellurium and the hydrogen is only a mere 0.1. So clearly, oxygen is going to give you the biggest difference in electronegativity, and therefore you're going to have the strongest hydrogen bonding in a compound with oxygen and hydrogen. Answer number 1. Question 17. Hydrocarbons are composed of the elements. Every once in a while, you'll see a question like this on a Regents exam, which is kind of like batting practice. Hydrogen, carbons. They're composed of carbon and hydrogen only. Answer number 1. Don't waste any more time with this question. Question 18. Which atom is bonded to the carbon atom in the functional group of a ketone? Now, if you're not sure where to look, if you don't know what a ketone is, you got a lot of studying to do. A ketone is one of the special organic compounds. You can find it on table R. Let's take a look at table R. You will find this generic structure representing a ketone. And you can see that the carbon has an oxygen double bonded to it. That carbon has to be centrally located in the structure. Here's an example of a particular ketone. This is called propanone, 3 carbons for prop. The anone ending tells us it's a ketone. And you can see the functional group right here, double bonded oxygen. So the answer to our question is oxygen, number 4. Question 19. 2 types of organic reactions are. Well, here we can't avoid it. We simply need to know what the different categories of organic reactions are. Here's a list of the 7 major organic reactions. For this question, we don't need to know too many specifics about them, but you probably will need that information later in this exam. For now, we just have the list: addition, substitution, esterification, saponification, fermentation, combustion, and polymerization. And then, from observing our potential answers, we see that only number 4 has 2 of our organic reactions listed. So number 4 is the correct answer. Question 20. The isomers butane and methylpropane have. Well, we're told that these 2 compounds are isomers. And if you recall, earlier in this video, we mentioned isomers. Let's take a look back. This was question number 4. We said that isomers were when you have structures with the same parts, but they are arranged differently. Now, I've taken the effort to draw out a butane and a methylpropane molecule over here for you. Your standard butane molecule, this one, has 4 carbons in a row, completely surrounded by 10 hydrogens. So the formula is C4H10, but the structure is this straight line of carbons. The methylpropane, on the other hand, has a 1-carbon side group, a methyl group, attached to the side of a 3-carbon chain. That's your methylpropane. It's still made up of 4 carbons and 10 hydrogens, but the structure is completely different. And that's going to make it behave differently in a chemical setting, so its properties will be different. So we're looking for an answer that gives us the same molecular formula, that's either 1 or 2, but it has different properties. Answer number 2. Question 21. In a redox reaction, which particles are lost and gained in equal numbers? In the redox unit, we are talking about the gain and loss of electrons. That's the definition of what's going on. The decoys they threw in here at you, hydroxide ions and hydronium ions, that's from the acid-base unit. And then we have the neutrons, which has nothing to do with this topic. Please remember these little catchphrases. Leo says Gur. When you lose electrons, you're oxidized. When you gain electrons, you are reduced. So our answer is number 1. It's all about electrons. Question 22. What is the oxidation state for a manganese atom? Well, they're telling us it's an atom. It's not an ion. And as you know, there's a whole list of rules for determining oxidation states. But rule number 1 is that if you have a neutral atom, the oxidation state is 0. So the answer to this question is 1. Question 23. Which compounds are classified as electrolytes? This is a question that comes from our acid and base unit. And keep in mind that all acids, all bases, and all the salts that dissolve in water are all electrolytes because they produce ions in solution. So what we're looking for is a combination of two compounds. They can be acids, bases, or salts. So let's check each of the compounds in the answers and see if we can figure out which ones they are. KNO3, that's potassium nitrate, that's a salt. And this is sulfuric acid. We know it's an acid because it starts with that hydrogen in front, and that's sulfate. So that's an acid. Well, this is the best answer. We can see it right off the bat. We have a salt and an acid. They're both electrolytes. But for review purposes, let's rule out the others. This compound here looks like it wants to be a base because it ends with OH. But this, be careful with this, this is what I call an organic decoy. It's actually an alcohol. Most chemistry classes haven't discussed organic chemistry before they're doing acids and bases. So hiding these little organic decoys in the acid and base area can be very confusing. This is actually an alcohol. Even though it has the OH does not become an ion in solution, so it's not a base and it is not an electrolyte. There it is again. So those two answers are gone. And then this guy right here, also an organic compound. It actually has an oxygen trapped in the middle. It's an ether, actually. And again, we haven't studied organic chemistry yet when we're doing acids and bases, so you might not recognize it. But of course, this is the Regents exam, and we anticipate that you will have covered all the material, so you should recognize these organic compounds. They are not electrolytes. Question 24. Which compound is an Arrhenius base? Recall that an Arrhenius base is a substance that produces hydroxide ions when it's placed into solution. The answer that should jump out at you is number 3. It's a classic hydroxide compound, calcium hydroxide, and all of the hydroxide compounds are bases. Again, here's an organic decoy. This is actually an alcohol. It has the OH, but it will not produce OH ions in solution because it's actually a covalently bonded molecule. Over here we have a salt, calcium sulfate, and carbon dioxide, which doesn't have the capacity to produce hydroxide, doesn't have any hydrogen in it. So answer 3 is our best answer. Number 25. According to one acid-base theory, a water molecule acts as a base when it accepts. Well, our Arrhenius theory of acids and bases says that bases produce hydroxide ions when you dissolve them into water. But here they're not asking about producing anything, they're asking about accepting something. So we're looking at a different theory. It's not the Arrhenius theory. The Bronsted-Lowry theory of acids and bases is no longer considered part of the New York State curriculum by name, but as you can see, it still shows up on their exam. They refer to it as one acid-base theory. What you need to remember about the Bronsted-Lowry acid-base theory is really quite simple. Acids are considered donators and bases are considered acceptors of hydrogen ions. So the answer to this question is number 1. Bases are the acceptors of hydrogen ions, acids are the donators. Number 26. Given the equation representing a system at equilibrium, and here's a very lovely equation, which statement describes this reaction at equilibrium? Remember that equilibrium is when the forward rate of the reaction is equal to the reverse rate of the reaction. Well, if that's the case, we're not talking about increasing or decreasing any part of the rate, so 3 and 4 are out. And if the rates of forward and reverse reactions are the same, we would not expect to see anything changing in terms of concentration. So answer number 2, the concentration of the nitrogen will remain the same. It's being constantly produced and at the same time being constantly consumed at the same rate, so there won't be any change in its concentration. Number 27. The acidity or alkalinity of an unknown aqueous solution is indicated by its what? You have 4 possible answers here. Let's rule some out. Percent by mass and percent by volume are 2 ways to measure concentration, not acidity or alkalinity, so those are gone. The electronegativity value is used to help determine what kind of bonds are present, so that's kind of a bogus answer as well. Surely you should recognize that the pH is a way to measure how much of an acid or a base a solution is. So the answer is 1. Question 28. The laboratory process in which the volume of a solution of known concentration is used to determine the concentration of another solution is called titration. This is the definition of titration. Distillation is a process of separating a mixture of liquids based on their boiling points. Fermentation is an organic process of producing alcohol. And transmutation is a nuclear process, so only titration fits this description. Number 29. Which list of nuclear emissions is arranged in order from the greatest penetrating power to the least penetrating power? Let's take a look at what the nuclear emissions are. There are 4 different types that we're considering here: alpha, beta, positron, and gamma. Alpha particles are rather large and they're very sluggish. They can't go very deep into whatever mass they hit, so they have the lowest penetrating power. Beta particles being much smaller, they tend to have a much better penetrating power, so we would refer to them as moderate. And the positron, very much the same size as the beta particle, also moderate. But gamma radiation is actually electromagnetic in nature. It's not a particle, and it has the greatest penetrating power of all of them. So if we're going to make our list in order from the greatest penetrating power to the least penetrating power, we have to start with the greatest, which is gamma rays. So 1 and 2 are out. We have to end with the one that has the least penetrating power, the alpha particle. So our answer is 4. And finally, question number 30. Given the diagram representing a reaction, lovely diagram, which type of change is represented? Well, we're starting off here with a very large nucleus, the uranium-235 nucleus, and we're smashing a neutron into it. So there's something artificial happening here. We're causing this to happen. And that great big nucleus of the uranium is being split into 2 parts, relatively large atoms, strontium and xenon in this case, and 2 small neutrons also being emitted. So we are splitting an atom. We're taking a large nucleus, splitting it. That process is known as nuclear fission. Answer number 1. You've seen this diagram before. It shows up in many different forms depending on what textbook you're using. Here, for example, is the way it appears in our textbook of reviewing chemistry, the Pearson textbook. Neutron smashes into uranium-235. You get your 2 daughter products and additional neutrons. Those neutrons can go further and break up other big nuclei, and you have a chain reaction. This is nuclear fission. So the answer is, indeed, answer number 1. And that concludes Part A on the June 2015 Chemistry Regents exam. Look for additional videos for Parts B1, B2, and C of this exam. Thanks for watching. You can access additional videos and materials for this and other chemistry exams at alchemtutor.com. For questions, comments, or permissions, please contact me at my email address at asnyder@alchemtutor.com. If you have interest in contracting tutorial services, you can also contact me through the website at alchemtutor.com.